the previous video, we have mentioned that we obtain the MED based on the slender brace column formula here equals to 77.1 kN meter. Now we need to determine the amount of reinforcement bar based on the design chart. First, we need to know what is the design chart that we are referring. Determine the locations of D by using the formulas here, which is the cover plus the length plus diameter of bar divided by 2. The D2 is 46 divided by the width of the columns. In the directions of the bending moment, you will have this 0.184. If you refer to the design chart, you have the design charts of D per H of 0.15 and also the D per H of 0.20. There is no chart for 0.184. With that, you will need to determine the AS Fy per BH FCK for the chart of both 0.15 and 0.20, and you will need to do interpolations accordingly. Substitute the NED 1002 into the formula here, you get this, and substitute the MED, which is 77.1, into the formula here, you get this. Refers to the chart D per H of 0.15. Based on the value here, draw a line at 0.64 and also a vertical line of 0.164. You will get the value of AS, which is close to 0.7. Next, you refer to the chart D per H 0.2. Draw a horizontal line at 0.64 and a vertical line for 0.164. You will get the AS FYK per BH FCK of 0.75. From here, you have the D per H chart give you 0.7 and 0.2 chart give you 0.75. You can interpolate the value for the D per H of 0.184. This is the outcome of the interpolations. With the given value of SCK, BH and FYK, substitute the relevant value, you will be able to obtain your AS required. This AS required will be required for you to compute the curvature of 1 per R, particularly for the factor KR. Remember that at the initial stage, when we want to calculate the KR, we assume it is equals to 1.0. The assumptions of 1.0 was made because during then we do not know the amount of reinforcement bar. Now, since that we know the amount of reinforcement bar, we will need to compute this KR based on the formulas here, where the N here is determined by the axial force divided by the area of the columns and also divided by the design compressive strength of the concrete. The design compressive strength of the concrete is determined by this formula, which is 0.85 times SCK divided by partial factor of safety of the concrete, which is 1.5. Your FCD will be equals to 14.2. Substitute the relevant value, you get your N. Now you need to compute this NU. It is given by this formula 1 plus omega, and this omega is given by this formula, which is the ratio between the steel and also the concrete. the area of the concrete of the columns times the design compressive strength of the concrete, and this is the area of the steel as calculated from the previous calculation step to be multiplied with FYD, design yield strength of the steel. The design yield strength of the steel is given by this formula, which is 0.87 times FYK. Substitute the relevant value here into the equation here, you get your NU. And assume your N balance is equals to 0.4. Substitute all the value of N into the formula here. You will get the KR equals to 0.577. With a new K now, substitute into the equation here, which you have already calculated originally the K dot and 1 per R naught in your previous calculations here. You will be able to obtain the new ratio of 1 per R of the curvature. Substitute the relevant value into the equations for E2. Now your M2 is equals to 33.6 when you multiply NED with E2. What you see here now, the M2 has been revised to a smaller value. Due to the revised KR here, you will need to redefine the new MED. As given in the equation here, your new MED will be equals to 54.2 kN meter. Again, substitute NED and MED into the formula, you will have new set of the ratios. Refers to the chart of D per H 0.5. Draw a line of 0.64 as calculated here. 0.64 and vertical line of 1.16. The intersection here will be about 0.5 AS FYK per BH FCK. Write down the value and refers to the chart of 0.2. Chart of 0.2 is here. Draw a horizontal line for 0.64 and the vertical line of 1.16. The intersection here, it will be nearly 0.55. Write down the value. Find the interpolations for the ratio D per H of 0.184. You will get this value. Now you recalculate a new area required. What you see here is the area calculated here in comparison to the previously assumed. It has been reduced significantly. That means you will need to revise the cathode again. With that, you will need to use the new areas for you to compute the KR. Go through the equations again until you find a new M2. Since the M2 has been revised again, you will need to use this formula for you to determine the MED. You will have a new MED here. Substitute the NED and MED into the equation here, and you will need to find the intersections point for you to determine the new AS based on the design chart. From the chart, you obtain the AS times FYK divided by BHFCK equals to this value. Through interpolations, you get this value. You will need to continuously loop the AS for you to define the KR until the MED become more or less constants. Then you can provide the amount of reinforcement bar accordingly. After providing the reinforcement bar, check the minimum bar area by using this formula. Substitute NED and FYK into the formula, you get this. And substitute the area of the concrete, which is the multiplications of the width and the height of the columns, into the formula, you get this. The provided reinforcement area is greater than as mean, therefore the amount of reinforcement bar is adequate. Next, you need to determine the maximum bar area. Make sure the provided area is not exceeded. Divide the provided bar area with the cross sections of the columns. It is about 2.5%, which is less than 4% of the area. Therefore, the amount of reinforcement bar area is adequate. Next, you will have to check the size of the link, which is 1/4 of the diameter of the main bar and at least greater than 6 mm, as represented by the formula here. You found the minimum bar link size will be 6 mm. And check for the spacing of the link based on the formula here. Your spacing of the link is governed by the width of the column, which is 250. You know that for the regions of lapping, the spacing need to be multiplied with 0.6. Multiply 0.6 for 250, you get 150 at the lapping joint. Therefore, the link provided, it will be 6 mm at the spacing of 250 throughout the column, but the spacing will reduce to 150 at the lapping joint.